Today, you'll learn how to turn the Shear tool into your very own modifier using geometry nodes. Unlike the edit mode version, this one's fully procedural and non-destructive, perfect for smarter modeling workflows. First, let's take a look at how the modifier works. We have many options here. We can choose the direction of the skew. Then we have the skew values. We can apply the effect on the x-axis and the y-axis. And if we change the direction to y, here you see the effect on the x-axis and the z-axis. Let's go back to the z direction, and now if we set the center to 1, the top part will stay in place. And as we go downward, the segments will deform gradually until we reach the bottom of the cube. Next, we can use a selection, so we can limit the effect on a vertex group. Lastly, we have the option to add curvature, and we can also invert the direction of the curvature. So let's dive in. We'll start in a new file, using ND primitives, add a cube. Set the origin at bottom, set the size to 2, set the vertex to 6 in all dimensions, and apply visual geometry to mesh. In my last tutorial about modeling a chair in a non-destructive way, I've created a simple version of this modifier. But today we'll dive deeper and learn more about geometry nodes. So if you've watched it, be patient or use the timestamps to skip the concept part. So in geometry nodes, we'll be using a set position node to push the geometry in the direction we choose. So if we type 1 in the x offset, as you see all the geometry moved 1 unit in the x direction. But we need each row in the cube's geometry to offset gradually from bottom to top. So we'll get this geometry height and convert it to a factor going from 0 to 1. So this row will get 0 effect, then 0.2, then 0.4, then 0.6, then 0.8, and the top row will get the full effect. So how to get the geometry dimensions? First, we add a bounding box node. These dark blue sockets mean they have vector data, which are x, y, and z values. So looking at the x-axis, these vertices have smaller values. And for the y-axis, these are the smallest, so only these vertices are the smallest in both x and y. And if we filter them by the z values, only this corner vertex will remain, so this is the minimum vector. And the maximum is exactly the opposite, which is that corner. So now we'll use a map range node to convert these values to a factor. Let's drag from the min socket, release and search for map range. The connections should go to the from min socket instead of the vector. Then connect the maximum here, and in the vector input we add a position node. And we'll leave the default values of 2min and 2max, so this position vector would be converted to a vector varying from 0 to 1. Next, we need the z factor to be able to control the x and y offset separately. So we'll add a separate xyz node and a combined xyz node, then connect the z output to both the x and y inputs. Then we'll add a vector math node. Drop it on this connection and set it to multiply. Now if we change the x and y values, we get the skew effect. Okay, now we'll repeat the same process for the other axis. Let's duplicate these two nodes. Connect the y output to the x and z inputs. Duplicate again and connect the x output to the y and z inputs. And let's check if everything is working fine. Great, now to choose which one will control the skew, we need to add a menu switch node. Here we want to switch between vectors. We currently have only A and B. So in the node settings, we'll add a new input and rename them. Okay, and now connect the different multiply outputs to their corresponding socket in the switch. Let's also set the default value to Z. Then connect the output to the offset. And to control it from the modifier panel, We'll connect the menu to a group input and call it direction. Now to expose this multiply value to the modifier panel, we drag from here, release and choose group input. Let's rename it to Skew and check the single value checkbox. Then we can connect this controller to the other multiply nodes, and let's test what we've done so far. Great, now to change the center, we will modify the vector coming from the map range. So we'll use a vector math node. Select subtract and subtract 1 from the map range vector. To control it from the modifier panel, we'll add a group input. Our data type is float, default 0, minimum 0, and maximum 1, and check single value, and we'll call it center. Then we drag from this socket, release and type input, and choose center. Now let's test it. Now to limit the effect to a selection, first let's make a vertex group. In edit mode, select the top part, press Ctrl G, and choose Assign to New Group. Okay, now instead of the bounding box node, we'll use attribute statistic. We'll plug the geometry, then we'll plug the position. Then to get the selection from the vertex group, just drag and drop from selection to the group input. And now we have this field here, and we can choose the vertex group we created. Now these sockets are gray because the data type in this node is set to float, but our position data type is vector. Now if we connect the min and max from the attributes to the map range, and change the skew value, the effect is applied only to the selection. Now, what about the curvature? Well, this was a little bit tricky for me as I'm not a math guru. And you don't have to be a guru either. In the end, if it works, then it's not wrong. I searched the internet for a math solution, and I learned that applying power to the factor will curve it, instead of being linear. And I couldn't find a power function in the vector math node, so let's make a workaround. Okay, let's separate this vector to manipulate each value as a float. Connect the X output to a math node. Set it to power. Set the exponent value to pi, and Blender will automatically convert it to its value. Then let's combine the result in a single vector. Repeat it for the Y and another one for the Z. Then for the exponent, we'll connect it to a value. Then connect the value to the exponent of the rest of the math nodes. Then connect the combined vector here. And for tidiness, let's group these nodes. Rename this input to exponent. And rename the group to vector power. And exit the group. And now we don't need this connection. Instead, I'll set the value manually. Now to control the amount of curvature, we'll use a mix node. Add a mix vector node, plug the original linear values in the first socket, and connect the curve vector to the second socket. So when the factor is 0, the skew is linear, and when we set it to 1, it becomes curved. Now we'll connect this factor to a group input. Check single value, set default to 0. And we'll call it curvature. Now how to get the inverse of this curve. I'm sure the following is not the best math function to do it. So if you know the right way, please share it with everyone in the comments, or send me a direct message on any social media platform. So here is my solution. First, I'll use vector math. Set it to subtract. Set the first vector to 1. And connect our mapped range vector output to the second vector. Then feed it to the power function. And duplicate the math node to subtract this output from 1. I accidentally connected this vector in the wrong socket. Now if we connect the result here, we get the opposite curve. Okay, now to switch between the two curves, we'll use another mix node. So we'll duplicate this one, connect the inverted curve to B and the power to A, and the output will go here. Now we need a new control for this one. We'll call it Invert Curvature. And check single value and set default to 0. And for better user experience, let's arrange our controllers in two panels. Click the plus sign and choose panel. Rename it Skew. And drag and drop these controllers inside it. Then add another panel. Call it Curvature. And move the controllers inside it. And bring the curvature panel below the skew panel. Also, the curvature controller should come first. If you've watched this far, congratulations! It shows how dedicated you are to leveling up your Blender skills. Make sure to subscribe, hit the like button, and grab your free Blender file from the description. And see you soon in the next video.